This is from 11.2, is it? All right. So 11.2, what is the combination formula? Let's talk about that first. So n choose r looks like what? It's n factorial over n minus r factorial, also times r factorial, right? Okay, so this is the extra bit compared to compared to the permutation formula. Okay, so instead of r we have n minus 2. Okay, all right, let's go ahead and do c here. So I've got n factorial over n minus this quantity, which is n minus 2, all factorial, over r factorial, which is n minus 2 factorial. So does that make sense here? We've got the r is n minus 2, so I put n minus 2 in wherever I see r. Does that look right? Okay with that? All right. So let's simplify, equals 6, I guess. Let's finish that off, equals 6. So simplifying again, this is n minus n. So that's actually, the n's are gone there, right? And then we have subtract a negative 2, so that's positive 2. So this is n over 2 factorial. And then we have n minus 2 factorial on the bottom. How's that? Okay, so far, did you get that far?
Yeah.
Did you get that far? You got that far? Okay. So what happens next then? This 2 factorial is just 2 times 1, right? So this is like divided by 2. So I could multiply both sides by 2 and get rid of this, which would make this 6 a 12. You okay with that? Okay, so we got a 2 in the denominator here. Let's multiply both sides by 2. All right. So let's move over to the side of the screen. So this n factorial is actually can be expanded partially to n times n minus 1 times n minus 2 factorial. That factorial means that this process continues all the way down until we have just 1. And we don't know how many terms that is, but that's okay, we don't need to know. But what we do need to know is that all of these factors that are represented here can divide off with all of those factors that are underneath there. However many they are, we don't know how many terms there are, we don't know what n is, but we know that these are the exact same set of factors on the top and bottom. Okay, did you get that far? Oh, good. Okay, so now we have n times n minus 1 equals 12, or n squared minus n. I'll subtract 12 from both sides. Minus 12 equals 0. Now, can I factor this? Well, I know factors of 12 are 4 and 3. They're only one apart, so that's good because we have a negative 1 here. So I could probably go n minus 4 times n what? Plus 3 equals 0, which in solving for n, I have n equals positive 4 and negative 3. All right. Now, we might have 2 possible answers, but we might have to reject one. So it looks like if I have a negative as one of my values down here, I don't think that's going to be okay. Is that right? All right, so I can reject negative 3 because I can't have a negative 3 things to start with. So if I have 4, choose 4 minus 2, does that equal 6? So 4, choose 2, does that equal 6? Well, I'm choosing 2 out of 4, so that's 4 times 4, choose 2. Well, 4 times 3 is the permutations divided by 2. That's 12 permutations divided by 2 for combinations gives me 6. Or you could just do this on your calculator. 4, choose 2, I think that should be 6. So n is 4. Is that what anybody else got here that got that question, or does that match up with what the solution is? Yes, I'm seeing some nods. Okay. Does that answer your questions about that? Okay. So this one, yeah, just make sure that you go from the formula, fill things in properly. This is really important, expanding this factorial and noticing the common factors to eliminate some things, yeah. Okay, anything else with this question or another question that's similar to this? You guys are good? All right.